So that's on the receptors, and on the structure comparison, you can find this structure similarity trees. Then you're presented with a page where you can click the Select Structures button, and it's similar to a lot of these other options that we have in the GPCRdb. So here you can select what structures you actually want to compare. So let's take a look at all adrenoceptors. So we have 72 structures already, so it's going quite fast. And if you then press go, so then what it does is it takes all these distances from all these atoms and then compares them across all structures, and then it starts clustering it into this very nice tree. And what you can see is that on the outside, we have a label based on the activation state of the receptor. And you can very clearly see that on one branch, we have all the inactive state receptors. And on the other side of this branch of the root node, we have all the active state receptors. So that's not too big of a surprise. But in general, we expect that these are the major changes, of course, that are happening. But then also within these branches, you see that there are several smaller subclusters that group together. So that actually means that those subclusters actually share some similarities. And overall, what we see is there is a tendency that structures that were released together at the same time, so probably by the same crystallographer or experimentalist, structural biologist who worked on this, maybe we used a specific setup, maybe used similar templates to do the refinement, and that is then also shown back here. And I'm just gonna toggle here to a different numbering naming scheme. So here we see mainly beta 2 structures, and then in the next branch we see also beta 1 structures. But you see also that again here the beta 2 they also have different branches, and so these are the earlier ones, the beta 2 receptor structures, and the beta adrenoceptors then have another cluster than the alpha adrenoceptors. So this is actually quite nicely classified according to the same classification that you would expect based on the similarity from a sequence. But as soon as we start looking at the active state, for example, we see there's a lot more variation. So we have some alpha adrenergics here, but the beta adrenergics, the beta 1 and the beta 2 adrenergics, are actually spread across the different clusters. So there is a much more similarity in the active states and clusters between the beta 1 and the beta 2 than actually between the beta 2s per se, for example. So that's already an interesting finding. And if we want to, for example, investigate this group of 3 beta 2 adrenergics and 1 beta 1, then we can select them here. And then if we want to see what makes them different from, for example, the other group that was clustered on the other side of the branch, then we can select them, and then we can move to the structural analysis here. We'll get to the structural analysis in a bit, just to highlight. So that was for one specific family, but we can also do this for larger data sets, such as, for example, let's just take the class A structures with high resolution, and then we select those, and then we do the comparison. What we see here is, again, a similar trend. So on one hand, we have mainly the active state structures. On the other side, we have mainly the inactive state structures. And here we have a different branch, a separate branch for the intermediate state. So it clearly shows that the parts of the activation state have a strong influence on the overall conformation of the GPCR structure. But what's also stands out in this case is that the internal coloring that we have shows that the grouping based on the different ligand types, so either the allergic GPCRs, the lipid GPCRs, or melatonin GPCRs. And you can already see from the coloring here, there's a lot more diversity than we saw initially for the adrenoceptors. So it's not per se that the lipid receptors only cluster together with the lipid receptors, but they also are also clustered together with some peptide receptors and even some nucleotide receptors. So that shows there's a lot of structural similarity going on, and that's stronger than the sequence-based similarity, because on the sequence-based similarity, they weren't grouped together, but on the structural conformation, they adopt similar conformation. So this gives you more than just the sequence-based view from GPCRs, but also the structure-based view.